The element of today has a notorious reputation as a lethal poison, whispered about in tales of murder and mystery. For centuries, arsenic, the element you chose in the poll, was the poison of choice for scheming nobles and desperate spouses, earning grim nicknames like the Poison of Kings and the King of Poisons. Its symptoms mimicked natural illness so well that it was nearly impossible to detect, making it the perfect untraceable crime, at least until chemistry caught up. Today we will discuss how this deadly element later transformed into a life-saving medicine. How did this substance, infamous for stealthy killings, end up on pharmacy shelves as a cure? Welcome to Q Chemistry, where we will discuss all the elements of the periodic system and also do experiments. And if you like these videos and want to see more, make sure to like, subscribe and hit the notification bell so you will never have to miss another episode. Also, if you want to influence next week's element, make sure to fill in the poll on the community section of our channel. So we could begin about the fact that these chunks in this cube are silvery gray. But let's start slightly different. In this cube we have a deadly poison. A poison that have been used for thousands of years. And it is good that these chunks are safely tucked away in this acrylic cube. They look quite nicely though. Now, it is a metalloid and not a transition metal, and we will later talk about what that actually means. Now, if you want to have this poison of kings in your possession, as a presse-papier, or you want to collect the elements like us, make sure to click on the link in the description and use the promo code so you will get a 10% discount, and you will also be helping out our channel. Now, for centuries, arsenic reigned as the undisputed ruler of poisons. In an era before modern forensics, it was terrifyingly easy to sprinkle some arsenic trioxide, the classic white arsenic powder, into the enemy's meal and get away with murder. Now, the victim would develop stomach pains, vomiting, and frailty over the days or weeks, symptoms much like cholera or food poisoning. Now, few would suspect foul play. As one historical writer stated, arsenic was the poison of kings, ideal for assassinating rival royals, and the king of poisons. Its stealth and potency made it a favorite weapon in power struggles from ancient Rome through the Renaissance. Arsenic's lethal resume is long and colorful. Arsenic was so commonly used to bump off inconvenient heirs and spouses that in the 1700s it picked up the nickname inheritance powder. Why wait for years for an inheritance when a pinch of arsenic could speed things along? Now, by the 19th century, arsenic-laced flypaper and rat poisons were household items, which meant that about anybody could obtain some without a few questions asked. No wonder arsenic became every would-be murderer's best friend. So, how did this king of poison finally lose his throne? Well, the turning point came with the rise of forensic chemistry in 1836. The English chemist James Marsh developed the Marsh test, the first reliable method to detect arsenic in victims' tissues. At last, prosecutors had finally proved to back up their suspicions, and the veil of the mystery around arsenic murders was lifted. Suddenly, poisoning someone with arsenic carried a much higher risk of getting caught. As news of the Marsh test spread, arsenic-wielding killers found themselves in trouble. Arsenic's golden age as an undetectable crime tool was coming to an end. The word arsenic traces back through a linguistic labyrinth to ancient languages. It likely started with the Persian word zarnik, meaning yellow orpiment, which was a gold-colored arsenic sulfide mineral known since antiquity. The Persian term passes into Greek as arsenikon. In Greek, arsenikon was associated with the word arsenikos, meaning male or potent, perhaps hinting at the substance's powerful effect. Now, the Greek weren't trying to be macho, it was more a coincidence than chemistry. But the name stuck. The Romans Latinized it into arsenicum, and eventually the French word arsenic gave us the English name we use today. Now, arsenic has been known to humans for a very long time. Ancient civilizations encountered arsenic in natural occurring minerals like orpiment, a gold-yellow pigment, and realgar, a fiery red-orange pigment. These minerals were so striking that they were used as cosmetic dyes despite their toxicity. Now, in fact, some historians suggest that arsenic compounds were among the first substances early alchemists and chemists learned to isolate. Arsenic metal itself was likely first purified in the Middle Ages. One recipe from around 1250 by alchemist Albertus Magnus involved heating a mixture of arsenic sulfide and soap to magically yield metallic arsenic. Clearly, people were playing with arsenic's power long before they understood the risks. Now, arsenic, As, is a chemical element, number 33 on the periodic table, smack in the middle of the table's infamous poisonous corridor, alongside elements like mercury and lead. It is classified as a metalloid, meaning it has the properties of a metal and a nonmetal. In its pure form, arsenic most commonly appears as a brittle steel-gray solid with a dull metallic sheen, which is actually what we see in this cube. Don't be fooled by that silvery look though, arsenic isn't malleable like a true metal. Wrap it with a hammer and it shatters like glass. When talking about arsenic, it's important to mention its place in the periodic table. Arsenic sits in the same group as phosphorus, directly below it, and just like phosphorus, arsenic shows some interesting behaviors with different forms of allotropes. If you want to know more about this, make sure to look at the video of phosphorus. Now, in the vapor phase, arsenic forms small molecules made up of 4 atoms, just like phosphorus does. If you cool these arsenic vapors, you can condense them into very reactive solid form, known as yellow arsenic, which is similar to white phosphorus. Arsenic also has a crystalline form where the atoms bond together in a more balanced, equal way. Now, it also has some peculiar behaviors. For once, if you heat arsenic, it doesn't melt into a puddle. Instead, it sublimes, jumping straight from solid to gas, a bit like dry ice. Now, what about this arsenic vapor? Well, it has an odor that reminiscens of garlic when it oxidizes. Now, to be clear, sniffing arsenic gas for a garlicky aroma is not really recommended or a safe experiment. Now, chemically, arsenic is a close cousin of phosphorus, which we made a video about earlier, which means it forms similar compounds and can react with a variety of other elements. In nature, arsenic usually doesn't roam alone as a pure metal. It is typically found paired with other elements. It loves to bind with sulfur, as in those pretty orpiment and realgar minerals, and with metals like copper, nickel, and iron, forming ores such as arsenopyrite. These combinations hide arsenic in the Earth's crust, ready to be released by mining or natural weathering. Unfortunately, arsenic in minerals can leach into water and soil, a fact that has caused serious groundwater contamination issues in parts of the world. Bangladesh, for example, faces a well-documented public health crisis from arsenic-tainted well water. In short, arsenic is all around us in small amounts. It's in the air, water, and even in living things. Tiny traces are present in foods like seafood and rice, usually in organic forms that our bodies can handle in stride. But add a little too much arsenic and you will quickly cross the threshold from harmless trace mineral to deadly toxin. Like my chemistry teacher used to say, there are no deadly substances, just deadly amounts. Now, while arsenic was infamously used for nefarious deeds, it also seeped into our everyday life in surprising ways. In the Victorian era, arsenic became a common ingredient in products that no one would expect. Take fashion and beauty, for example. Victorian women, striving for the era's ideal of a pale complexion, significant wealth and refinement, sometimes dosed themselves with arsenic wafers or diluted arsenic solutions. Yes, you heard that right, they ate arsenic on purpose. In small doses, arsenic can cause the skin to lose pigment and take on a milky pallor. Women mixed white arsenic trioxide, with vinegar and chalk and ingested this concoction to achieve a ghostly fair look. Now, this practice was risky, to put it mildly, but in those days the motto might as well have been beauty before health. There were even reports of rural folk in Austria, the so-called arsenic eaters, habitually consuming arsenic to enhance their complexion and boost vitality, building up a tolerance the way one might accumulate to a spicy diet. Of course, the line between beautifying dose and a deadly dose was thin, and some beauty seekers paid it with their lives, or lifelong health issues. Now, arsenic also found its way into colors of the 19th century. The Victorians loved bright, vibrant pigments for wallpapers, paint, and fabrics. The problem? Some of the most eye-catching greens and yellows were made with arsenic compounds. Shayla's green and Paris green were two popular pigments that owed their vivid green hue to arsenic. Now, homes decorated with fashionable green wallpaper could slowly poison their occupants, especially in damp rooms where mold would metabolize the arsenic and release toxic gas. It's a cruel irony that Napoleon's exile home on St. Helena had rooms decorated in arsenic green wallpaper, leading to one theory that his living quarters exhaled poison with every humid breeze. After the dangers of arsenic pigments became widely known, these colors were phased out of art and decor, but not before sickening who knows how many. In agriculture and pest control, arsenic was the hammer for every nail. If you had a rat problem, arsenic-laced bait would solve it for you. Insect infestation in the orchard? Well, sprinkle some arsenic compound and watch the bugs vanish. By the late 19th century, arsenic-based insecticides like London Purple, Paris Green, retooled from the paint to pest killer, and later lead arsenate and calcium arsenate were widespread use on crops. These were effective at killing pests, but they also left toxic residues. Now, farm workers handling arsenic sprays sometimes developed neurological problems. Not a surprise in hindsight, given they were essentially dousing trees with poison. Arsenic-treated fruits and vegetables could even carry small amounts of residue to consumers. Arsenic remained a popular pesticide until the mid-20th century, when alternatives like DDT and later organic pesticides took over. By the 1960s, awareness of arsenic's long-term health effects finally pushed it out of most pesticides, though some arsenical weed killers persisted a bit longer for tough infestations. Even beloved animals weren't left untouched by the arsenic craze. Arsenic-based tonics were commonly given to racehorses and livestock in the 19th century as a stimulant. A performance enhancer of sorts, a solution called Fowler's solution, potassium arsenite, became a go-to pick-me-up for racing animals and sometimes people too. Trainers believed it would improve a horse's appetite, coat shine, and stamina. It wasn't entirely superstition. A very small dose of arsenic can boost the metabolism, but it was playing with fire. Now, considering its deadly reputation, it is hard to imagine arsenic as a healing agent, yet arsenic has been used in medicine for millennia. In traditional Chinese medicine, for instance, arsenic sulfide minerals like realgar were used in small amounts to treat ailments, with careful preparation to reduce toxicity. Now, Western medicine too dabbled with arsenic. In the 1700s, English doctor Thomas Fowler concocted Fowler's solution, a 1% arsenic tonic, and it became a fashionable cure-all. By the 19th century, Fowler's solution was prescribed for everything from asthma to arthritis to eczema to leukemia. Patients would take a few drops in wine or water, and some did report improvements. Likely because arsenic can stimulate bone marrow and immune activity in low doses. However, long-term use often led to cumulative poisoning. Now, the true medical breakthrough for arsenic came in the fight against one of humanity's great scourges, syphilis. By the late 1800s, syphilis, a sexually transmitted infection, was rampant and notoriously hard to cure. A slow, debilitating killer if left untreated. Now, Paul Ehrlich, a German physician-scientist with a bold idea, believed in finding a magic bullet, a drug that would target disease-causing microbes without hurting the patient. After testing hundreds of compounds in 1909, his team discovered arspheniamine, also known as zalvarsan, and nicknamed Compound 606, as it was the 606th compound they tested. This new drug was an arsenic-based chemical designed to attack the syphilis bacterium. Remarkably, sulfarasan worked. It became the world's first effective treatment for syphilis. Now, clinics started administering sulfarasan to syphilis patients, saving many from the disease's disfiguring and fatal late stages. However, sulfarasan was no perfect magic bullet. Preparing and injecting it was cumbersome and painful. And because it was still essentially an arsenic compound, it had significant toxicity. Patients often suffered side effects and needed multiple rounds of injections. In time, a slightly improved version called neosulfarasan was developed, and together these remained the standard syphilis cure until the 1940s, when penicillin, a true magic bullet, replaced them. Even so, salvarsan was a game changer that proved arsenic, when cleverly applied, could save lives rather than end them. Now, beyond syphilis, arsenic found other therapeutic uses. In the 19th century, doctors used arsenic-based potions to treat illnesses like asthma, psoriasis, anemia, and even cancer. There was a fine line, though, between quackery and sound medicine. Some patients' medicines were basically just arsenic in disguise, but a few arsenic treatments stood the test of time. Now, in particular, arsenic trioxide, white arsenic, was used in tiny doses as a treatment for leukemia in the late 19th century and early 20th centuries. With mixed success, though. This fell out of favor as less dangerous treatments were developed. But arsenic was never entirely forgotten by the medical community. So let's fast forward to the late 20th century, where arsenic made a medical comeback in a big way. Researchers in China, drawing partly on traditional medicine insights, revised arsenic trioxide for a specific kind of cancer called APL. Now, APL is rare, but a deadly subtype of leukemia. And by the 1990s, scientists have discovered that arsenic trioxide could induce remission in APL patients, effectively causing the cancerous cell to self-destruct. This was astonishing, considering how toxic arsenic is in healthy cells. The trick was that APL cells were uniquely sensitive to it. Clinical trials confirmed the effect, and in 2000 the US FDA approved arsenic trioxide as leukemia treatment. Now, combined with other drugs, arsenic therapy can push APL into long-term remission for many patients, turning a once fatal cancer into a highly curable one. Arsenic-based drugs have also remained in use for some parasitic diseases. Melarsoprol, an arsenic-containing medicine, has been used in Africa for sleeping sickness, a brain infection caused by parasites, especially in late-stage diseases. Now, this illness is almost uniformly fatal if untreated. And while melarsoprol is extremely toxic, doctors dread its side effects. It's sometimes grimly nicknamed arsenic in antifreeze. It saved many lives where no other treatment was available. Thankfully, less toxic therapies for sleeping sickness are being developed, but arsenic had a role when options were few. Now, it's important to note that when doctors are using arsenic as a drug, dose is everything. The dose that can knock out leukemia or parasites is carefully calibrated to be just below the dose that would seriously harm a patient. Patients receiving arsenic trioxide are monitored closely for side effects like heart rhythm changes or liver enzyme spikes. Now, by now you might be wondering, outside of medicine, do we still use arsenic for anything positive today? Well, the answer is yes, though often indirectly. And researchers are even exploring new frontiers for this old element. One significant modern use of arsenic is in electronics. Now, arsenic becomes even more fascinating when it's combined with gallium to form gallium arsenide. This material is not just used to make superfast transistors, it's also used in LEDs. Gallium arsenide is known as a 3,5 semiconductor because gallium comes from group 3 of the periodic table and arsenic from group 5. When mixed in a 50-50 ratio, gallium arsenide crystallizes similar to silicon or germanium, which are pure group 4 semiconductors. The electron structure stays the same, but the atomic nuclei alternate. One has a proton too many, and the next a proton too few. Now, one special feature of gallium arsenide compared to traditional semiconductors, how it handles electrons and holes. Holes are just spots where an electron is missing. In gallium arsenide, both the extra electrons and the holes move easily in the same direction at their lowest energy levels. That makes it very easy for an electron to fall into a hole and release energy in the form of light. That's why gallium arsenide is so good for making LEDs. Now, arsenic can also play a role in doping silicon semiconductors. Pure silicon on its own is a pretty poor conductor at room temperature because only a few electrons get excited enough to move freely around. By doping silicon with arsenic, which adds extra free electrons, you turn silicon into a much better conductor. On the flip side, if you dope silicon with group 3 elements like boron, which has one less electron, it creates holes instead of adding electrons. These holes help carry the electric current through the material. Now, if you want to know more about the applications of gallium arsenide, take a look at this video about gallium. Another domain where arsenic left its mark is wood preservation. For decades, lumbermen for outdoor use, think playground equipment, decks, fences, were pressure treated with a mixture of containing arsenic. The most common formula, chromated copper arsenate, CCA, prevented rot and insect damage extraordinarily well. Now, the wood from CCA treatment could last for decades without succumbing to termites or fungi. All thanks to arsenic being lethally unappetizing to pests. This was a great success story for durability, but over time people grew concerned about arsenic leaching out of the wood and into the soil, or coming into contact with children playing on it. By the early 2000s, regulations in the US and the EU phased out arsenic-treated wood for residential uses. Now, these days, alternative preservatives are used for most consumer lumber, though. CCA is still used in some industrial settings or in countries with different regulations. Old decks and play sets with CCA wood continue to slowly release tiny amounts of arsenic into the surroundings, a subtle reminder of the material's persistent nature. Now, arsenic has also been deployed in warfare, as if it hadn't caused enough human misery accidentally. During World War I, chemists weaponized arsenic into toxic gases like ewicide, an arsenic-based blister agent. Fortunately, these were not widely used before the war ended, but stockpiles existed and were disposed of later. Now, in the Vietnam War, the US military sprayed Agent Blue, a herbicide containing an arsenic compound, to destroy crops and ground cover. The ecological and health impact of those actions added another dark chapter to arsenic's history. Now, engineers and scientists work on filtration systems to remove arsenic from well water and soil remediation to clean up old industrial sites. Scientists also finding innovative ways to harness arsenic for good. Recent research has explored arsenic containing nanoparticles to target cancer cells more precisely. And isotopes of arsenic are being tested for use in medical imaging to help diagnose tumors. So next time you hear the word arsenic, don't think of the villain sprinkling white powder into goblets of wine. Think of the doctors and the scientists who saw that poison as a potential cure, and by daring to use a little of the danger, saved lives. As our understanding of chemistry continues to evolve, who knows what other unexpected heroes might emerge from the roster of infamous elements. Arsenic, the deadly element turned lifesaver, shows that sometimes the most toxic characters have redeeming arcs after all. Now, if you like learning about poison, make sure to watch this episode about lead, where we will discuss if lead poisoned the Roman Empire next. If you think I missed anything, make sure to leave it in the comments, and if you like this video and want to see more, make sure to like, subscribe and hit the notification bell so you will never miss another episode.